Hey, and welcome to this video on Viem. We're going to be talking about Viem because in future videos, we're going to be diving into the AA SDK, which is built on top of Viem. So what I want to do is I want to introduce you to these low-level concepts first. So things like client and account and what those mean before we dive into the AA SDK that has more customized versions of these concepts for account abstraction specifically. So whether you're here just because you want to learn Viem or whether you're here because you want to dive into the AA SDK next, you're in the perfect spot to learn about Viem. So what is Viem? Viem you could just think of as a library that makes it really easy for us to interact with Ethereum nodes, EVM nodes. So you can think of it as an alternative to Web3 or Ethers.js if you're familiar with those libraries. If not, don't worry. We're going to be going over the core surface area for everything that you need to be effective with this library. One thing that I do want to point out before we jump into this video is that this is meant to be a high-level overview. I'm not going to bore you by going through the documentation. You can definitely do that yourself and jump in here by going to viem.sh and checking out the docs. They're really, really good. So if you need to know specific parameters and what their types are for different methods that you're interacting with, definitely go there. What this video is meant to be is a fast run resource so that you can jump into the library and start being effective with it right away. And hopefully these core concepts will stand up from version to version to version so you don't have to go remaking this video every couple months as they add new features to this library. Awesome. Okay, so let's go ahead and dive in. I'm going to be breaking this video up into 3 parts. And for each part, I have a different picture that is going to represent what we're trying to do with code. So each one of these represents a code example that I'm going to be going through and showing you a bunch of different configurations and ways that you could set these things up so that we can get familiar with the core surface area of Viem. You can see on the left-hand side of this picture here, we have Viem. Enclosed inside of it are 2 concepts, an account and client. These are going to be the first 2 important concepts to get familiar with when you're coming into the Viem library. The account is going to represent a private key. It may be a private key that you hold locally within the script or maybe on your local machine, or it could be a key that's accessible via a JSON RPC call. Really, you're calling out and saying, hey, is it okay to sign something? And then you'll get the signature back. Right? But at the end of the day, the account represents a key that we could potentially access for signing things, right? And then we could take that and be able to get things like the address, and we can get things like the public key, things like that from the account. Then we have this client. And the client is going to be the way that we interact with the EVM node. So it's going to be configured in such a way that it knows how to interact with an EVM node. And we can just make these really nice requests that are going to make it easy for us to do things like fetch data or send a transaction or deploy a contract or read some data from a contract. All those types of things that we're going to see in these examples, the client is going to make that really easy for us to do. So I've chosen this icon here that looks like it's sort of like mapping, right? It's sort of like a little router that's helping us route our request to an EVM node so we don't have to know the low levels of how JSON RPC works or the specific methods. We could just use this nice interface to the EVM node. Awesome. So that's going to be our first example. The second example I want to jump into real quick here, but we're not going to, we're going to just start with talking about it, and then we'll go into the code example a little bit later. So you can see here now on the left-hand side, I've added one object, which is going to be this contract. So in this code example that we're going to go into a little bit later, I'm going to talk about this idea of a contract, which is another interface that we can use to interact with a contract that's inside of an EVM node that's been deployed to an EVM node. So you can see here that this contract is highlighted, much like this one is inside of the EVM state itself. So the contract inside of Viem is going to represent that contract. So it's going to know what the different methods are that are defined on that contract inside of the EVM. It's going to know how to read data from those methods. It's going to know how to write to those methods. And it's going to know how to deploy that contract so that we can treat it kind of like a contract, right? But there's that asynchronous part to it, which is we're going to actually be sending data to an EVM node that's going to get interpreted by the virtual machine itself. And then we could target other contracts and be able to interact with those contracts as well. Mostly what we're going to be using here underneath the hood is going to be ETH call and ETH send raw transaction. These are going to be the low-level JSON RPC methods that you don't really necessarily have to see when you're working with Viem, because we're going to have some nice APIs that we can interact with through the library, through interfaces like the contract, and we'll also see we can do it through the client as well. Finally, we're going to be taking a look at events. So if you have written Solidity before, you're familiar with this concept of an event, or maybe you've heard of it as a log. When we send transactions to an EVM chain, you can see we have a bunch of transactions here. I've chose this little icon like our business here is done. We've done this transaction. We have a bunch of transactions, and what they do is they create these receipts, and inside of those receipts are going to be these logs that from the Solidity side we think of as events. And these events are going to be things that we can emit to say something has changed, something has happened on chain, so that maybe we need to update something on our UI for our users so that our users can see some new data on their interface, on their web app, or maybe it's something that we need to change in our database so that when users do interact with our app, they see that new data. All of that is going to be shown in this example when we go through the different methods that we would use to read events or to listen to events if we want to trigger some functionality when those events occur. So great. These are going to be our 3 code examples that we're going to dive into. We're going to start with this really super simple one where we're just going to be taking a look into the account and client. So let's get ready to dive in for part 1. Okay, hey, and welcome to this first part on the Viem speedrun, where we're going to be going over the account and the client with a couple code examples so you can get a little familiar with how this stuff works. Awesome. So I have a very basic repository set up here. I'm going to make a similar one down below that you can use that's going to be set up in the same way so you can start from scratch in case you want to do that. Awesome. So what we have here is we have a couple dev dependencies. This is going to allow me to use TypeScript here. And then a couple dependencies. One is going to be my .env, which is going to allow me to pull in my Alchemy API URL. I'll have a sample.env inside of the repository I make available for you, so you can do something very similar. Just rename it to .env and then pull that in, as I'll show you in a moment. I'm going to be pointing to Arbitrum Sepolia. You could point to whatever chain you want. Ideally a testnet if you're just testing some stuff out. And I'll show you how to configure that chain in a moment. You can use a couple different chain definitions, or many different chain definitions from Viem. Great. And then we're also going to be using Viem at 2.9.15. This is the latest version available as of this video. May be slightly different for you as you're going through this. Awesome. So let's go ahead and get started. One thing I should point out before we do is in the future parts 2 and 3, we're going to also be compiling Solidity. So I'll create an extra folder for that so we can compile it with the Solidity compiler, be able to pull in things like the Solidity contract bytecode and the ABI so we can read and write to contracts. But for now, all I'm going to do is create a source file where I can create a TypeScript file that we'll call one account. And I'll name this one dash so that we can keep track of which step this was. This is step 1, and then we'll have steps 2 and 3. And this is going to be all about the account. That's really what we're learning about here is the account and a little bit about the client, but we're going to learn more about the client as we go into parts 2 and 3. Awesome. So for the account, what I want to do is I want to make it so that every time we run this particular script, I want to focus on the same account every time. And if we're going to focus on the same account with an EOA, we want to have the same private key behind the scenes. So for that private key, I'm going to generate this on screen. Definitely do not recommend you using this private key because obviously I'm going to be making it public to everyone who views this video. I will not be using this private key for any production purposes. I'll just use it to send some test ether to so that we can use it for this particular video, send some transactions and contracts, deploy them to our testnet here to Arbitrum Sepolia. Okay, great. So my private key, I'm going to go ahead and generate on the terminal here using Node.js. So what I'm going to go ahead and do is call Node.js here. This is going to load up Node.js so that I can run some console commands inside of Node. And what I'm going to do is I'm going to require the core library from Node called crypto, and then I could say random bytes 32. This is all we need to be able to grab a private key. That's a valid private key right there. And every time I run this, I'm going to get a different private key. If I want to actually get that in a format that Viem can accept, I'm going to have to say toString, and then I always forget whether it's hex or 16. I guess lucky this time. So there's my private key. So I'm going to call this private key, and I'm going to 0 exit, so that way hopefully that's the right format there. And there's my private key. If you were using this, we might want to secure this private key, not put this in here, maybe at least put it in the .env. But in this case, I just want to make it obvious where this is coming from so that we understand how this account is being generated. Cool. So what I'm going to do is I'm going to go from a private key to an account. There is a method from Viem called private key to account, which actually comes out of, let's pull this out. It's private key to account from VM/accounts here. So this will be able to get me this method here, which hopefully I named that correctly. There it is right there. We can pass in a private key, which is going to be hex. It's a 0x encoded string, and then we can go ahead and pass that in there and get back an account. We're going to take a look at what an account looks like. I'm going to go ahead and say private key to account and pass in this private key. And now we took our private key, and now we have an account. This account is going to mathematically link that private key to a public key, and then we can take that public key, and we don't have to do it ourselves because the account's going to do it for us, but we could hash it and take the last 20 bytes, which is going to be our address. So let's go ahead and log out the account to see all the things that the account does, everything that's inside of it. So I'm going to run this by using TS node, and I'm going to say source/one account and go ahead and run that. All right, great. So now what I have inside here, you can see this is the account that we've logged out. I mentioned in the overview that there's a couple different accounts that you can use. In this particular case, we're using a local private key account. As you could tell, we have our local private key inside of this script. I did mention that you could also have a account that represents a private key, but over some sort of a connection where we can go ask the user if a signature is okay. But in this case, we are just using the local private key, right? So we can just sign things pretty easily inside of this script. And then you can see that we got the public key generated here from the private key, and then from that we get the address. We also get some utilities in here like sign message, sign transaction, and sign type data that we could use to sign these different pieces of data with our private key. Awesome. So that's what you get with an account. So now we understand a little bit about the account. What we're going to want to do with this account is we are going to want to use it to start to learn things about the account. In the future, we're going to use this account to actually sign transactions and send them to the testnet in the next two parts. But in this case, let's just learn some things about the account, like maybe what is the balance of this account, and maybe what is the nonce, what is the transaction count of this account here. So if we're going to do that, what I'm going to do is I know that get balance is going to be an asynchronous call. So I'm going to use something called an iffy here so that I can get await. So this little syntax here is an immediately invoked function expression, just so that I can get the await keyword in here and I don't have to use promises. Hopefully at some point that will just become available on the top level file. But for now, let's just go ahead and use this await here. And what I know I need to do first is I need to create a client. So our client is going to be a public client, which we can get from Viem. So we have this method called create public client. Now, if we take a look at create public client, and I want to for a second, this is the definition inside of Viem. There's something important to point out about clients. So you can see here, let's close out of a couple things to kind of zoom in on this a little bit. You can see here what's happening inside of Viem is it's saying create client. So we've mentioned this idea of a client is something that you can use to interact with an EVM node, right? So that's pretty straightforward. We're creating a client with some of these parameters. But then we're doing this thing here called extend public actions. So this is another concept in Viem that's kind of helpful to know about. This idea that you can use actions, and these actions are going to be things that you can configure your client with. Right? So these actions are going to be different methods that you can set up your client with. In this case, we are extending our client with public actions. So what are public actions? Well, we can kind of jump into this to learn more about what public actions are. So you can see there's a whole bunch of things here. And you'll notice one thing in common with all these different methods is they are all read methods, right? They're all methods where we are trying to read something from the blockchain, whether we're trying to create a filter so that we can filter different events, which we'll talk about in part 3, or you're trying to get a block, or you're trying to get the chain ID, or you're trying to get an ENS address. You know, these are all read public methods. So that's what it means when we were saying public methods, public actions. This is going to be as opposed to wallet actions that we'll see in a moment, and then test actions as well. So this is what we're doing is we're creating a client, and they were extending it with these public actions. So now we could do all of these things. So if we have this client, we could say create public client, and then the create public client is going to take a couple parameters. So you can see here, what's really nice is in Viem, you can click into these things and you can see the definitions of these and good examples here. So in this example, you could see that they are passing in a chain from Viem chains, which is going to be mainnet, and then it's passing in a transport, which we'll talk about what a transport is in a moment. So let's go ahead and just put in a chain here. So for the chain, you're going to want to get these definitions out of Viem chains. So we can do an import up here from Viem/chains. And if we go to Viem chains, you can see all the definitions of all these different testnets, right? So or not just testnets and mainnets, right? These are all the different chains that we might want to use. So we could use, let's go ahead and pull in Arbitrum Sepolia, which is the one that I have pointed to for my API URL. And if you click on this, you can actually see the definition for Arbitrum Sepolia. One of the more important things to point out here for our purposes is that every chain has its own ID. This is to make it so that every transaction is unique across all these different chains, right? Because they are all EVM chains. We could potentially have a transaction that could be valid across all these different chains, except if you sign it with a particular chain ID, then it is not valid across the different chains. It's only valid for the one chain, right? So this is kind of like a nonce for chains, is that ID. Cool. So what we're going to go ahead and do is we're going to plug in the Arbitrum Sepolia to that chain. And then what we're going to do as well is, what is the other parameter that we had to pass in? It was called, let's take a look at the example, transport, right? So we're going to pass in transport. Now for transport, you can have a couple different transports. You can define your own transport. Most commonly, you're going to use HTTP. And this is what I'm going to use in this case. You might also use WebSockets. In this case, I'm going to just be using HTTP so that we can make calls over HTTP. We're just going to make some network calls to be able to interact with my API URL. So my API URL, I pointed out, is inside of my .env. So what I'm going to want to do is I'm going to want to import .env from .env, and then I'm going to say .env.config. Now the default config for .env is to just pull in my .env from the top level here where I'm running the script from. And so it's just going to go ahead and do that. So when it does that, it should equip my process.env with my API URL. So I should be able to do process.env.api URL and be able to pass that into HTTP so we can communicate with our EVM node. And then VM knows that this is going to be Arbitrum Sepolia. So we can sign it with that chain ID. And we have all the other things that we need defined inside of that chain definition there. Great. So now we have a client who is equipped to know how to communicate with this particular EVM node. What we could do at this point is we could start to ask questions about our account, which is going to be the main purpose of this first part here. What we want to do is I want to get the balance. So let's get the balance. We're going to say await client.getBalance. And then for the get balance, so again, you can click into these things, which is great. You can see the examples. Here you can see that for get balance, we are passing in an address. There are other parameters that you can pass in here as well. So like if you wanted to know the balance for an address for a particular block, those types of things, you can find these sorts of things in the documentation at vm.sh. So definitely check that out there. But in this particular case, that's all we really want to do is we just want to pass in the address for the latest block. So we're going to go ahead and say address, account.address. And this is going to get us that balance. Now let's go ahead and see what the balance is of the account right now. This is a brand new private key, right? I just generated it in front of you. So we kind of expect that this is going to be a zero balance, right? I'd be surprised if it was more than that. So let's go ahead and clear this out. And I'm going to go ahead and say I'm going to go ahead and run this, right? I'm going to say npx ts node. And then source one account, and there it is, 0n. And you'll notice one thing about VM is we're going to be using the big int library, which is the native library to the latest JavaScript runtimes. So n is going to denote that we're using big int here. This is able to handle bigger numbers. So this is opposed to what we used to do with JavaScript libraries when we were trying to do bigger numbers is we'd have to pull in a big number library. But in this case, we're just going to use the native big int here. So if you see that n, that's what it means. It's a big number. So we don't lose precision when we get to a certain size. All right, great. So what I want to do now is I want to load this account with some Ether. So I'm going to do that on the side screen here. I have an account that has some Arbitrum Sepolia, so I'm just going to send that over to this account. If I'm going to do that, what I need is the address, and then I will go ahead and send that through. So the account, let's just go ahead and log out the address here so that we can get that. And we'll see it right there. There's my address. So what I'm going to do is I'm just going to send some Arbitrum Sepolia over to this account. Great. So I sent over 0.01, so that should be pending just a moment. That should be plenty enough for us to be doing all of our transactions here. So now if I go ahead and run this, hopefully we see that 0.01. Now this is not obvious to me that this is 0.01 Ether because I'm not a robot. I don't really know what that means when I look at all those zeros. It's like a lot of zeros. So if I want to see this in a way that I can actually understand it, we want to think about this in Ether, whereas this number right here is denoted in Wei, which is the smallest denomination of Ether. So we want to actually see this in a format that we can understand. So let's go ahead and do that. There's a utility for this called format Ether that we can pull from Viem. So if we go ahead and do that, this is going to turn this Wei balance into something that we can understand, which is going to be Ether. Now, if you're like me, there's something that I want to point out here, which is there's format Ether and then there's parse Ether. And these two are sort of the reverse of each other, where if you had something that was in Ether, let's say it was like 0.01 and it was a string and you wanted to turn that into Wei, you would use parse Ether. Whereas if you want to get something from Wei and you want to see it in Ether format, you would use format Ether. If you're like me, then you probably get these confused very often. Something that somebody pointed out to me a long time ago, which I thought was kind of a cool idea, is format you can think of as for Matt. If you're thinking of the user, the developer, yourself, maybe you're named Matt. If you're thinking of somebody named Matt, it's for Matt to understand this balance, right? So this is like kind of coming from a data format that we wouldn't understand, and we're taking it and we're providing it for Matt. Whereas the opposite way, when we're taking it from Matt or from a human and we are passing it into something that should be understood by machines, we would use parse Ether. Just something that makes it easy to remember. Every time I use these methods, I always think about format. So that's kind of helpful there. So anyway, format Ether, we'll go ahead and use that. And then we're going to go ahead and say this. And hopefully now this is actually something that's useful. Sorry, I'm like in the way here. So we'll just go ahead and move that over there. So now you can see that it's 0.01 Ether. So now we can actually see that that is a useful piece of information. We know that that is Ether there. Awesome. Okay, so let's go ahead and clear this out so we can make that a little bigger. Now that we have the balance here, we're just going to do one more thing, which is going to get the transaction count, just to show you another useful piece of information. But I'm not going to go through, like I said, this is not going to be a reading of all the documentation. You could do that yourself. You can find all the different methods that you might need. You can even click in, like I've been doing, to the public client and then go to the public actions, and you can see all the different things that you can do here. If you're familiar with the Ethereum JSON RPC API, you can find all of these things documented as methods, or you could find the actual documentation for these methods inside Viem, however you choose to go about it. So I'm not going to go through each one of these, but we may touch on a couple more of these as we go through parts 2 and 3, especially transaction receipt. I see there is going to be one that we're going to want to use, send raw transactions, these types of things. So, okay, let's go ahead and do, we're going to go ahead and just get our transaction count, which is going to be our nonce here. So let's go ahead and do client.getTransactionCount. And we're going to pass in the address. It's going to be the account address. And we're going to go ahead and log out the nonce. So let me do that. And what we should see here is when we log out the nonce, let me save my file before running this, we should see that the nonce is currently 0, right? Because we haven't sent any transactions. Maybe what we'll do is after we go through parts 2 and 3, we'll use the same private key and we'll come back here and see that the transaction count has increased. Awesome. So that is showing us a little bit about the client and the account. In the next 2 parts, we're going to be diving into reading and writing to contracts and then reading and writing events. So let's go ahead and check that out. Parts 2 and 3 coming right up. Okay, part 2. So now we're going to go into contracts. We're going to be reading and writing and deploying contracts. So let's go ahead and get that started. The second thing that I'm going to be doing here is creating a second script. And this is going to just be called contracts.ts, not TTS, TS. Let's get rid of one of these TS's. All right, awesome. So what I'm going to do first is I'm just going to move this private key up into the .env. That way we can access it from the .env and just pull it in everywhere. And I'll do that right here. We'll toss that up there, and then maybe we will make that available to our first account. So I can commit this afterwards and not worry about having sensitive. It's not really sensitive, but you know, I don't want to be encouraging any bad practices. So I'll pass this up into a .env and just not commit that up there. So let's go ahead and do that. So now we should be able to say process.env.private key is our private key, and then we should be able to pass that in. So what is this getting mad about? Oh, okay. So it thinks that this might be undefined, which is true. It might be, but I'm just going to go ahead and say, we're going to say that that's going to be hex. I promise it's going to be hex. So should be good to go there. And if everything's still working okay, we should see that this account is working properly here. All right, awesome. So that's still working okay. So now we can use that private key in our second account or our second script to be able to access the same account here in our contracts. Great. So we have that set up. Maybe I'll pull over most of the same stuff here so that way that we don't have to recreate a lot of that. And we'll see how much of these imports we need here. Probably a lot of the same stuff, but maybe not all. But we'll pull over that for now. Okay, so what I do need to do for this step that's going to be a little bit different from the last step is I'm going to want to create a contracts folder. And inside of our contracts folder, I'm going to want to set up a contract that we're going to want to do a few things with. So let's just call this like let's name it something fun. Fun.sol. I don't know. I'm not thinking of anything. I just want to name it something different so that you can see that I named it something when we take a look at the artifacts. So I'm going to name it fun.sol because why not? So not import, but pragma, solidity. And then we're going to use, let's see. So I'm using right now for my global Solidity version. If you go to the Solidity documentation, you can see that there's a whole bunch of different ways to install Solc, the Solidity compiler. So I'll link that down below. I use Solc select. This is something I installed a while back. But it's something that is a Python library, I believe, that allows me to be able to change between these different Solidity versions. It makes it really easy, so I like to use it. So I think I have installed right now 0.8.25, so that's great. So let me just go ahead and use 0.8.25, which I believe is the latest version currently on this video. So we'll go ahead and use Pragma Solidity 0.8.25, and we'll set the license identifier MIT. Great. Cool. So what we're going to do with this contract is we're going to name it fun, and we're going to have some fun. so let's just go ahead and create a public X is going to have the value 125 in there because I like to think that I can generate random numbers in my head. I don't know if that's even somewhat true. Are we pseudo random? But 125 is the number I came up with. And then what I'm going to do is I'm going to take a constructor that is going to pass in an X here like that. And then we're going to also have a variable called change X that we're going to go ahead and also pass in something here like that. Awesome. Okay. So this is going to allow me when we deploy the contract, and I'm doing this so that we can see how to pass in variables when we go to deploy this contract. We could pass in a variable that's going to set X as something different. Well, then we won't see the 125. Let's avoid this first, and we'll come back and we'll add in a deploy parameter later. So I'll come back and I'll change this, and then we'll see what that looks like. So I'm just going to leave this as 125. We're not going to take any constructor arguments for now, but I'll leave that function changex in there for a little bit later when we want to go right to this contract, right? Awesome. So let's go ahead and compile this contract now that we have that set up. It looks like it's a valid Solidity contract. I'm going to go ahead and compile it using Sol-C. So I always forget how to do all these flags and everything. Luckily, I have it in my console history here. So I have this optimized combined JSON. I'm spitting out this JSON file that's going to have the ABI and the binaries inside of it. Those are the two things that I really need. Is going to be the ABIs and the binaries. So the ABI is going to be what's going to define my contract so that VM can know what are the different methods that this contract has and what are the constructor arguments, that type of thing. And then the binary is going to be what I need to deploy the contract. So we'll see that in a moment. In this case, instead of game.sol, we're going to call this fun.sol. And instead of game.json, we're going to call this fun.json. So we're going to spit this out into a folder called artifacts, where we're going to store our fun.json. So it's mad because there is no folder called artifacts, and I will go ahead and create one. So let's create a folder called artifacts, and we'll go ahead and spit out fun.json. Sweet. So there it is. Okay, so if you've used Foundry or Hardhat in the past, but you never compiled these directly yourself, this probably seems kind of low level. This is, it's nice though, I think, to be able to see all this stuff that's happening here. So here we actually use the Solidity compiler, and what we're doing is we're spitting out this artifact, which is going to have those two things in there, which is going to be the ABI. So here's the ABI. This is what our contract looks like, right? It has a constructor that takes no inputs, because I commented out the input. And then we have a changex method that takes an input, which is going to be that x there, that's a UN256, outputs nothing. And then we have this variable x, which is a public variable, so it creates a getter, a view function, that takes no inputs and is going to output us the UN256, the value of x, which should be 125 when we deploy this. And then finally, we have the binaries here, which is going to be the bytecode, which we're going to go ahead and use to deploy this contract. One other thing that's important to point out here is that with the Solidity compiler, you can compile multiple contracts. So you're going to see that the JSON here has it listed as contracts, and then it has the name of the file, fun.sol, and then the contract fun here. If I name the contract something different, this fun would be something different. Same with the file, right? It doesn't have to be the same. You could have multiple contracts in the same file, that sort of stuff, and then you would see multiple contracts listed out here. Awesome. So this is going to give us the ABI and the bytecode, which is what we need to be able to deploy and interact with this contract so we can come back into our contracts file over here. So let's go ahead and play around with this file now. What I want to do is I want to be able to deploy this contract using this account that we had in the previous example, which has some testnet ether in it now on Arbitrum Sepolia, thanks to me sending that over in the previous video. So what I'm going to do here is I'm going to go ahead and do the same thing that I did in the last video, which is or the last part here, which is I'm going to go ahead and create a async await iffy so that we can go ahead and use the await keyword. And then what I want to do here is I want to create another client. This time, I'm going to create a wallet client. And the reason I'm going to create a wallet client is because I'm going to want to do some wallet actions. And the wallet actions in this particular case that I'm going to be using is going to be first deploying the contract. And then if we want to use the changex method, it's going to be a transaction that's going to interact with the changex method. So those are both going to be wallet actions, because what we're doing is we're signing the transaction with a private key with an account, right? So these would be wallet actions as opposed to the public actions that we talked about in the previous part. Awesome. So let's go ahead and do that. I'm going to create a public client. So our client, or wallet client, sorry, create wallet client. And our wallet client should take the same parameters as the public client with the addition of the account, which makes sense, right? Because you're creating a wallet client now, and this wallet client needs to know who's going to sign the transactions, who's going to pay for the gas. So this is going to be the account there that's going to pay for the gas. So what we're going to do is we're going to feed in the account, and we already have the account above, so fortunately that's already in there. Now this client is a little bit smarter than our previous client, where it actually knows about the account, so it can start to sign messages, sign transactions, and send them to the RPC. Great. So then we're going to use the other things that we had before, which our chain again is going to be Arbitrum Sepolia, so we can use that import there. And then our transport is going to be the same thing as our previous file, which is going to be the process.env.api URL. And boom, we have ourselves a client. Now, one thing that I am going to do here is because this wallet client, I am going to want to read data from the contract as well. So I'm going to want to write to the contract. I'm going to want to deploy the contract, but I'm also going to want to read that value X to see that we deployed it properly. It should be the value 125. And if it is, then we know we deployed the contract properly. In order to be able to get that method, I'm going to want to extend this with public actions, which I'm going to import from Viem. So you can see that public actions is now coming in here from Viem. So now we have a wallet client that is also extended with the public actions, which is what we saw in the previous part where we saw that we were creating a client and extending it with the public actions. So we get all those methods if we want to read data from the chain. Okay, great. So now we have a client that can do both. Sweet. So let's go ahead and do something with this client. So the client should have a method that's like deploy contracts. And we'll see how that one works by looking at the example in there. Let's go to deploy contract. And deploy contract, we could see that in this example here, it is telling us that it's going to return a transaction hash, which is useful because, well, it's useful to know that because we're going to have to use that hash to be able to go look up the receipt, which is going to have the stuff that we want inside of it, like where was this contract deployed. The transaction hash is just going to represent the transaction, so we're going to want to go retrieve that transaction hash. And then we're going to pass in the ABI and the bytecode. Fortunately, we have that from our artifacts that we put into our artifacts folder, so we can go ahead and import that. And then the account, do we have to use the account again here if the account is in the create wallet client? I'm not sure about that, but we can find out, see if it requires us to pass in that account again. Cool. So what I'm going to do is I'm going to go ahead and import. We're not going to need these parse ether and format ethers, so I'm just going to get rid of this out of, overdoing it. We don't need that create public client. But what I am going to import is I'm going to import, let's call this our fun JSON from ... artifact / fun.json. So that's going to be our fun JSON. Inside the fun JSON should be the ABI and the bytecode. So if we want to pull out the ABI and the bytecode, we could do it. It's going to be called bin because it's the binaries inside of our artifacts. We need to go into the fun JSON and then remember that the fun JSON has contracts and then contract / fun .sols colon, so contracts. Let's see. Let me just copy this over so I don't get it wrong. This whole thing here. Awesome. Cool. So now we get our ABI and our bytecode. So we should be able to pass that in. Our ABI is going to be our ABI, and then a bytecode is going to be our bin. And let's see if we need that account. Is it getting mad because we need the account? No, it looks like it should know that this is the account that I want to sign with, right? So I don't think we need that account again. So we should get back a transaction hash. So if we get back our transaction hash, we should be able to spit that out and we should be able to run with it. So let's see if that works. Oh, it's getting mad. Element has an any type explicitly. Oh, wait. Shoot. This is wrong. And maybe you saw that when I was doing this a moment ago, which is this should be contracts, right? And then inside of that is an object, which is going to be contracts of fun.sol / fun. So this should really be like this. And then that. Yeah, there we go. It was even auto completing it. So that's pretty great. So there we go. And now it's getting mad about the bytecode, which it's saying, hey, we expected this string to be a 0x string. You can kind of see that there, not assignable to 0x string. So, again, here we're going to want to, well, the binary, we want to check if this binary is in fact 0x prefixed, which it's not. So it's a good thing that we caught that, the compiler caught that here, which is great. So what we could do is we could just do 0x bin. And look at that. Hopefully the squiggles, yep, they went away. All right, awesome. So it caught it, here, which is super nice. It's nice to use TypeScript with low-level crypto libraries because it'll catch stuff like that. Sometimes libraries are okay with you passing in non-0x prefix strings. Sometimes they're not. So it's always good to catch that as soon as you can as a developer. Otherwise, the error that you might get back might be some weird error that like surfaces because of like something that went wrong with some hashing and then some signature validation. You know, like you get these bad errors back sometimes when you pass in the wrong type. So it's nice to get that right away. Awesome. So let's go ahead and run this and see if we get that transaction hash back. So now we're going to run tsnode/to contracts and see if we can get ourselves a transaction hash. All right, that looks like a transaction hash to me. So if we want to go actually check this, we can go to Arbitrum Sepolia Etherscan and actually be able to put in this transaction hash and be able to see that indeed this is a contract that was created here on chain. Now we could pull this contract address over. This is the contract that we just deployed, and then we could use this to read the data. But here I don't actually want to like have to depend on my going out to Etherscan and then pulling the contract address over. So I want to actually make it so we can take that transaction hash, get the receipt and get the contract address out of that, and then read that public X variable, and then maybe change X, read the change to X, and then go from there. So let's go ahead and do that. So what I'm going to do is I'm going to go ahead and say read transaction receipt. So let's go ahead and do that here. So I'm going to go ahead and say receipt is going to be await client.getTransaction receipt. And we're going to plug in, well, let's see the example here. Is it, yep, not letting me go in now. Oh, bummer. There it is. Okay. So we can see in this example, okay, that is what I thought. We pass in a hash as an argument, part of the object that we pass in, and then we can see that we pass in the transaction hash. So we should just be able to do that. And we're going to get back a receipt. Now, because we had the types in here, we should be able to read out of the receipt stuff like, I think the contract address is named contract address, and it did autocomplete that for me at the last moment there. So it looks like contract address is going to come back. Now it's possible that this could be a string or it could be null or undefined if there is no contract being deployed. So we do want to do like an if check here to check whether or not a contract was deployed. I do expect a contract to be deployed because that's what our transaction is the contract deployment transaction. So we'll just go ahead and optimistically go into this branch of logic here and do something with the contract address. So what we're going to want to do with the contract address is we're going to actually want to read that public X variable. So let's go ahead and do that. So I am going to say, let's get X is going to be await client.get read contract. Is that what it is? There it is. Okay, read contract. And then let's take a look at the examples to see what's inside a read contract here. Okay, so we pass in a contract address, ABI, function name, and args. Let me just pull all this out so I don't have to go back here. Okay, I'm going to comment this in so that way I can just do the address is going to be our contract address. The ABI we have from above. The args is going to be nothing. So I wonder if can we leave that undefined? Do we have to pass in args? I don't think so if we don't need anything, because we're just going to be targeting the function X in this case. So we don't need to pass any inputs. We're just going to get outputs. Looks like it's totally okay with that. So we do not need to pass in any arguments here. And we'll get back the value for X, which should be 125. So let's go ahead and see if that is indeed 125. So if I run this, we're deploying a new contract, so it's going to take a moment. Then we're going to read that receipt, and we get back 125 with that N showing us that it's big int. Awesome. That's exactly what we wanted. So that's really great. There is one other way that I want to show you that we could read this storage variable X. Because it is a storage variable and it's in a public database on the Ethereum nodes in the EVM virtual machine state, which we come to consensus as a public network, we could read this out of the public database, the consensus database, and be able to just read that value without the actual going to the contract and having it respond to our method. So if you wanted to do that, In previous videos, if you watched our intro to Solidity or read any of the documentation on like Alchemy University, you may be familiar with this idea of storage variables. In this particular case, the storage variable right here is in storage slot 0x0. This gets allocated contiguously, so this is the first one in 0x0. If we wanted to read this directly, what we could do is we could come over here and we could say, instead of read contract, I just want to show how we would do this. This is another method that's going to be available on the client, is we could say x is equal to await client dot get storage at. I think it's get storage at. Let's see. Yeah, okay. And get storage at is going to allow us to pass in an address and then a slot. In this case, the slot is going to be 0, so we can actually just pull that out there. So we're going to go ahead and say address is going to be our contract address, and then our slot is going to be 2 hex 0. Cool. And then we will go ahead and log out X. Now in this case, you'll notice one thing that's very different here, and this is why I wanted to show this example, which is kind of helpful. So 2x we do have to import if it didn't do it already, so hopefully now it will. One thing that's really useful about this example is it's a little bit different in the sense that here we're reading the contract and we're passing in an ABI. This ABI is telling Viem that the thing that we're reading, this X variable, is a uint256. So when we get this back, we get it back as a big int. So it's being parsed as a number, right? But when we say get storage at like this, we're going straight into the database to pull back this value. This is just going to give us the raw data, right? It doesn't really know what type this is. It could be a number, it could be a string, it could be like part of an array or a bigger data type. So it's just going to give us the raw data. I expect this to come back as 32 bytes of raw data, in which case we're not going to see 125, but something that would be like the hex representation of 125. Let's go ahead and get that back and see what happens here. So we're going to read this back. We're reading that slot directly. So what we expect back is something like that. So 07D, if we went into node and we typed out 0x7D, there it is, 125. Okay, so you can see that. You can see that there. 0x7D is going to be 125. That's the value that we're getting back. So that is, in fact, what we expected, which is great. So now we have the ability to go to this method through the ABI, the contract value X, or we could go through storage and be able to pull that back straight out of the storage slot. What we want to do next is we want to actually write to the contract as well. Well, actually, maybe one other thing, right? Because I did say that we would come back here and we would also change this so that we could pass in a constructor variable, right? I did want to come back and do that. So in this case, we could just leave X blank because we're going to be passing in something at the constructor time anyway, so we don't even really want to, there's no point in initializing it if we're just going to reinitialize it through a deployment variable. So let's go ahead and just pass that through. So if we wanted to do deployment variables, I just wanted to show how to do this as well. This deploy contract, we should be able to pass this through in here. You can see that there are, okay, so we actually don't see that in the example code here, but you can find this in the documentation. It's either called args or parameters. I always forget. I think it's args. So pass in args here, and then for this arg, let's just do a different number that's not 125. Let's go with 127. So I'm going to go ahead and pass that through. That's going to be our one argument. And then, if it's actually parsing this, maybe it would tell me that 2 arguments is invalid. Sometimes you'll get that like compile time verification depending on whether the ABI is available in the right spot. In this case, because we're parsing it as JSON, I don't think we're actually getting that type inference, which is unfortunate. But that's what you get sometimes. I think that's something that's actually being actively worked on, so it might be something you might get in the future. Maybe you're already getting it by the time this video has come out. So anyway, 127N, that is something that we could pass in there. That's going to be our constructor argument, and then we're going to go ahead and read this, and hopefully we will get back 127N. So let's go ahead and clear all this out, exit. Oh my goodness. Okay, clear this out, and then we'll run this, 2 contracts. All right, we got an error. It's saying inputs were not found on ABI, and maybe you already know why. I make some mistakes on these live streams, and this is, one of them, which is I forgot to recompile my contracts, right? So that's what I need to do is I need to recompile the contract to fun.json, and now this fun.json should actually have inside of it here a constructor argument. Whereas before, when I didn't recompile it, it wasn't in there. So this is actually something that's being caught in Viem. So let's see, there's the constructor, and now here's the input, because it knows that this ABI does not take a parameter, right? So this is actually something that we can catch before trying to send the transaction on chain, which is fortunate. So let's go ahead and run this now. We compiled it, and now we'll run it, sending in that value, and there it is, 127. Awesome. All right, so now we've deployed the value 127 as a constructor argument. You could pass in many arguments inside of here, and now we want to actually write and read again. So let's do this. We're going to write and read. So we have a read contract, we're going to write, and then we're going to read it again. So let's do 3 of these things. We're going to do a read, and then we'll do a write contract, and then we will read again finally at the end. Cool. So this write contract is going to be something pretty similar. It's going to be function name with some args, the ABI, and the address. So pretty much everything that we have here, right? Except that we're going to want to be calling changex. And with changex, we're going to be passing in some args. The args is whatever we want to change it to. I'm just going to make it 129. So that we go from 127 to 129, and we can see that that is working properly. So hopefully this will work, right? I'm going to log out 127, and then we're going to change it. We're going to do 129, and then we're going to see 129 here. So we're doing this all on chain on Arbitrum Sepolia. It's going to take a second, you know, like it's going to deploy a new contract. It's going to read that contract, write to the contract another transaction, and then it's going to read from the contract again. So we'll see this come through, but, you know, I'll have a little bit of a pause here. So to deploy the contract, 127, write to it, 129. So we've changed the state. We've been able to deploy the contract, read to the contract, write to the contract. But something that you might want to do here, which is at this point, like, this is pretty repetitive, right? This idea that each time we have to pass in this address, that's a contract address, and each time we have to put in the ABI. So if you were in this case and you wanted to be able to just say, like, man, I wish I just had an object that represented the address and the ABI, this is where you could use a contract from. So there's this method in Viem that you can call that's called getContract. And with getContract, you could pass in address, which is going to be our contract address, and then ABI. And now we actually have an object that we can use to interact with these different methods. What is it getting upset about? Oh, and client, right? So the other thing that you're going to want to use, right? So in all of these cases, we're saying client.read contract, right? Client.read contract and client.write contract. So if the contract is going to be smart enough to be able to send requests, which we want it to be, right? We want it to be able to just read and write to this contract. We need to give it the client, so we don't have to use the client every time. That's going to be nice as well. So instead of read contract here, what we're going to do is, all right, let me leave that code there so I can show you how much simpler this becomes. We're going to say const x is equal to contract.read. And now there's something special that happens here in Viem, which is it's actually going to use the ABI to generate methods, type-safe methods, on this read namespace here. So we could say read x, and this is actually going to go ahead and generate that method and be able to show us with type inference that there is a value x. And so this x is block scoped, is the same one as this one. I'm just using this. I'm going to delete the code down below, but I just want to show you how much simpler this gets. So if we want to write to this contract, now we can say write, and we can pass in, let's do 132n. And then if we want to read this one more time, and now that this is so simple, let's just log this out like this, right? We'll read like that, and then we'll read like this again. And this should be write.changex, right? Which is the name of the method. And then we'll pass in that 132. And what is it getting upset about? Oh, okay. So for these methods, when you use write, when you pass in the arguments, you need to pass them in as an array like that, right? So you'd have multiple arguments. So there we go. So it got that. We needed to pass that in, 132, and that should replace all of this code down here, right? So that's a lot cleaner. When you're going to be using the contract multiple times and you want to pass it around to all your different pieces of code, you could use this contract interface to be able to interact with your contract that's already deployed on chain. So let's go ahead and do that. We're going to go ahead and run this again. Should be one new contract, 127, write to the contract, 132. There we go. Awesome. So that is reading and writing and deploying contracts and also using the contract interface. In the next part, we're going to be going into events, reading and writing events and seeing the different ways that we can work with those. Okay, part 3, we're going to do some contract events. So we already have from step 2 set up this contract interface, which we're going to use for this step 3 as well. But I'm going to create another file here, which we're going to call events.ts. I'm going to make use of the fact that we already have this contract deployed. So what I want to do here is I want to also just log out the contract address. All right, so let's log that out. So that way we have this for step 3. And then we could just pull over that contract address rather than having to redeploy it every time. We could just focus on the same contract address. Let's go ahead and do that. So I'm going to go ahead and do to contracts.ts. And here we go. We have the contract. So let's clear that out. So we have the contract address here. What we're going to do is we're going to pull that over into our events. So maybe one thing that I will also do, let me pull this over, is I'll pull over a lot of the stuff that we need from here, right? So we won't need all of this, but we are going to need, well, we'll only need a public wallet or a public client, right? We won't actually need our wallet because in this case, I'm just going to be, well, I might want to write some contract methods so that we could trigger events to happen. So let's go ahead and also get our private key here. So I'm just going to pull in a lot of this code that we already have here from our previous example. And then we'll have our account, and then we'll have a contract address. And then what we're going to do inside of our async await here is the same thing that we did on step 2, but we already have a contract address. So I'm going to just go ahead and do const client is equal to await create wallet client. And this client is going to take our account, is going to take transport, which is going to be the HTTP, and then the process.env.api URL. And then finally, it's going to take our chain, which is going to be Arbitrum Sepolia. Awesome. Okay, so those are all the things that we need to do to create the client. And then we are going to want to create a contract. And the contract is going to be await get contract. And since we already have a contract deployed, we're just going to say address is contract address. And then the ABI is going to be the ABI that we're passing in, and then the client here. Cool. So now we can actually refer to this contract address every time. We are probably going to want to change that contract address slightly, or well, not slightly, to a new contract because we're going to have to emit events on our contract. So if we're going to want to listen in to events or read events that have happened already, we are going to want to first emit some events from our contract. So let's go ahead and do that first before we go any further. We're going to want to emit some events from our contract. So let's just do one event here and call it X was changed. And we're going to say, let's make this fun. We'll do the from and we'll say to. So these are the two things that are going to be what X was and what X is becoming. So let's go ahead and say X was changed, and we're going to emit this. Emit X was changed and pass in what X was, which was a state variable, to what X is becoming, which is what we're passing in here. And then we're going to want to do the same thing down below, right? All right, great. So we're just emitting two events, the same event each time, but from two different places. Once in the constructor when we're passing in that initial argument, and then once in changeX when we're passing in a new argument that changeX does something else. Now what we want to do is we want to compile this. Can't forget about compiling it to our artifacts JSON. And now what's going to happen inside of here is we're going to actually have a new thing on the ABI that Viem can now use and create a type-safe interface for it, which is going to be that X was changed event. So we're going to make use of this because our ABI is being put into that contract interface. We're going to make use of this X was changed name to be able to actually listen into this particular event. Now, we're not going to really be doing a lot of criteria for this. The only thing that we're going to care about is this particular contract. Whenever this X was changed event was triggered, that's when we're going to want to listen in, whenever this was emitted. You could also do things like you could index on particular parameters if you wanted to. In this case, we did not make either one of these parameters indexable, but if you add this index keyword into the event, you could do that there and then add that in as your criteria. Won't do that here. We're going to keep it really, really simple, just reading events from the contract. So let's go ahead and jump into that here. We'll go ahead and say await contract get events. So there's our get events. There's also watch event, which we'll use in just a moment, but let's just do get events for the moment. And then get events is going to be something that we can actually key in on, where we could say X was changed and get this interface for this event. And then we can pass in a criteria. Now the criteria here is maybe we'll just make from block and just do 0n, so that way we get all the events that have ever occurred, and we'll grab all these events and then we'll log them out, right? And what we should expect is if we run the contracts, the step 2, the event should be triggered twice, right? It should be triggered once when we deploy it, and then a second time when we go ahead and change it over, right? So let's go ahead and do that, and we'll get a new contract address, and then we'll read all the events that occurred. Great. So let's run step 2, which is going to deploy the new contract. We'll get a new contract address, and then we'll pass in a step 3, and then actually read all the events that have occurred. So you can see we went from 0 to 127, 127 to 132. So there should be 2 events. Here is the contract address. We'll pass that into step 3. Let me just make sure I didn't paste in more than I meant to. Very zoomed in. So, all right, cool. So we'll pass that in there, and then we'll read all the events. Great. So we'll say npx ts node source/3 events. And then we should be able to read all the events. And it looks like there are 2, right? So the first event was from 0 to 127. We can see some more information in here. We're not going to go into events too deeply in this video, but topics is going to be the names and index parameters. In this case, we just have the name of the event that we're filtering on, which is going to be this event named X was changed. We have some data in here as well, which is going to be the data that's being emitted. It's part of this is going to be the value that it was, and then part of this is going to be the value that it is. So it was changing from 0 to 127, and 7f is going to be that 127. Here's the block number, transaction hash that it happened in, log index, all of that, right? And then here we see from 127 to 132. So you can see here's the data. Up to this point is the 127. This is what it was, and then 132 from here on out. Great. And our topic is just the same here as it was there, which is going to be that X was changed. You can see that it's 5E7, B4F, and then 5E7, B4F. So the topic that we're listening to, that we're actually subscribing to in this case, that we're filtering for, is going to be the event name X was changed, or the signature of the event more specifically. Okay, great. So that is reading events from our contract. Now what we want to do is we want to watch for events, listen into events, and then run some functionality based on that. So what I'm going to do is, let's just change this so that we do, instead of get events, I'm going to do watch events. X was changed. And then there is, so in X was changed, let's see, watch event. Watch event is going to take arguments. So you could pass in for a watch, you could pass in, so this example is a little bit different from how we're going to do it. I think we just need this onLogs method here in this particular case. They're creating a event filter in this case and then using that event filter. But for us, we are just sort of using this X was changed on the watch event. So I'm just going to go ahead and do onLogs and then log out the logs here. Console.logs, logs, logs, logs. It's logs all the way down. Okay, great. And then now we don't need this event anymore. So whenever X is changed, then we're going to go ahead and spit it out. So what's actually going to happen is when we run this script here, it's going to, it's just going to hang, because it's just waiting for, it's creating an event listener that's going to be listening for these logs that are coming through. So Node is actually going to wait for this to be closed, which we're not closing it here. So if we actually ran this right now, we would just be sitting here. And now I don't expect to see any events because right now I'm the only one who knows about this contract address, unless somebody happens to be looking it up on Arbitrum Spolia and sending transactions my way. So I don't see anything right now. So maybe we need to kick that off. Maybe we'll do something to kick it off. Let's go ahead and do that. So I'm going to cancel the script there, and what I'm going to go ahead and do is just kick it off. Maybe every couple seconds we'll send something that's actually going to change X. So let's do send timeout. And we'll start X at like, let's say 55, and then we'll just increment it every time, right? So let's do X++, and then we will send it over and change it each time. So let's go ahead and do that. We'll say, and the timeout, set interval. We're going to want to do this on a regular interval so we can see these come through. So we'll do it like, I don't know, how often is a good amount? 5 seconds. We'll say await, and then contract.write, and then it's going to be change X, and we're going to change X from, or to whatever X is now, right? So it'll be 55, and then X++, and then something else. So this is again going to be array, so we can pass in that value each time. Different arguments. All right, sweet. So this should work every 5 seconds. We're going to see, let's make that 3 seconds. Let's just do, I don't know, maybe that's too often, but let's go ahead and do that. We'll run 3 events, and then after 3 seconds, we should see an event come through, which should be 55, and then 56, 57. So, okay, so it started out 132, went to 55. Now it's 55 to 56, and then 56 to 57. And then one more, 57 to 58. Oh, I missed that one. 57 to 58, and then 58 to 59. So you can see I'm going to continue listening into each event as they come through until I cancel this and then close the listener for those events and stop changing X over and over again. Awesome. So that is reading events, and that is listening to events. So that's everything that we need to know about the core concepts of VM to be efficient with this library. So hopefully you enjoyed this video. I look forward to jumping into AA SDK in the next video.